The invention of the microscope was as important for biology as the telescope was for astronomy. Remember how we learned about Galileo took a telescope, he goes, whoa, Jupiter has moons, or the Venus has phases, and all these discoveries that led to understanding that the Earth goes around the sun? This is just as big. Looking at things through a microscope can reveal worlds that no one ever knew about. And so I want to get into the discovery of this a little bit. I'm going to have expose you to the names, and some of them, I want you to have heard of them. I'm not going to have a test question. Do you know what, Anthony von Leeuwenhoek did, right? I'm not going to do that, like load the names on you, but you should at least know them, or at least be exposed to them. But one that I am going to want you to know. This is a picture of a microscope that was built by a very important scientist in a lot of different fields. He also used telescopes and stuff, but Robert Hooke was his name, okay? And he built this, the microscope. This is a picture of the one he used. He didn't invent the microscope, but he made a good, just kind of like Galileo didn't invent the telescope. Well, Hooke didn't invent the microscope. Here's the eyepiece, and you have a lens here, and it goes through, and you have another lens here, and you can look in this tiny little drop of water or whatever it is. And what this part of the contraption is here is like a candle, because they didn't have, actually it would be like a kerosene lamp. They didn't have electricity for light bulbs and stuff. And then this sort of glass ball would focus that light onto the spot he's looking at, so he has a much brighter light. So this is, like I said, this is a early microscope. And I wish we could use microscopes in the classroom, but we're not in the classroom. I don't know. It is what can you do, right? So anyway, I do want you to know that once they invented the microscope and started looking at stuff on a microscopic level, they realized very important and profound things about life and how life actually works. And so this part, I do want you to write it down. And remember, his name is Robert Hooke. It has an E on the end, but the E is silent. And Robert Hooke in 1665, so, he was, back about the same time as Isaac Newton and stuff like that. But he used a microscope and coined the term cells. If you ever wondered where the term cell comes from, we don't use the word very often. Cell, like to be a small room. I guess prison cell is the only place we still use that term. But back in his day, there were monasteries and stuff. A lot of people would, go to live in the monastery, and they had their little rooms. It's kind of like a dormitory, I guess. And those were called a cell. It means a little room, right? And so when he looked under, especially this cork from an oak tree, he's noticed these very tight geometric shapes, right? And he said, wow, this kind of reminds me of the rooms you see in a monastery. So he started calling them cells. And that's where the word comes from. And so I think let me shift myself over here. This is a picture that he drew, right? And I love seeing the actual work of the scientist involved. And here he's showing this is a leaf and this stem and stuff like that. And he got some of it, the cork, it's called the cork cambrium is what it's called. And he put it on the microscope and he drew this really nice picture. So a lot of the early scientists were also very good artists. Art is an important science skill. And so that's where the name came from. Now, something I'm going to say we're going to get to later on in more detail is animal cells aren't necessarily as geometrically, laid out like bricks the way plant cells are. Plant cells have a thing called a cell wall. And it's like a rigid structure made of cellulose, which actually is a kind of sugar, right? And so it's wood, if you want to call it that, or fiber. I mean, you have a lot of fiber in your diet. That's the cellulose. It's the cell walls. And so it gives a nice firm structure to the plant, right? And where animals, except for our bones, that's different. That's calcium. We're pretty floppy. Our cells are squishy and all weird shape, whereas the plant cells have this geometric shape to it. And so he was looking at the plant cells, called them cells. Okay. I'm going to pause it here and go on. So write it down. And then we'll go pick it up in just a second, where we're going to get into the 3 ideas that are known as the foundation of cell theory. Okay? So write it down, and I'll see you in a minute. Okay, welcome back. We just dealt with Robert Hooke. By the way, I didn't have you do this, and I would like you to. Say the name Robert Hooke. If you say it out loud, it'll go through your brain. It'll help you remember it. Say it again. Robert Hooke. Go. Robert Hooke. Go. Robert Hooke. Say it. There's going to be a lot of vocabulary in this unit, and so I'm going to this is the one guy I'm going to want you to have to remember. The other names I want you exposed to, okay? They are coming up. So, ladies and gentlemen, cell theory.